My name is Matt, and over the past year, I've been going through the process of switching game engines from Unity to Godot as a background project while working on my game. While learning as much as I can about the engine, I've been trying to highlight potential workflow showstoppers and help smooth these areas out with idea mockups and even pull requests that add additional editor features for everyone to use. Much to the dismay of my attention span, I've sort of gotten lost in the sauce that is the Godot engine improvements. So could it finally be time to go full focus on my actual project? Nah. Let's put that on hold yet again, because recently I came across a few weird quirks with one of the fundamental building blocks of Godot, scenes. Now, I'm not the first one to discover this, but thinking about some of the implications has become a little worrying for some of the workflow goals that I'd like to achieve. And I thought it'd be best to explain my thoughts in video form. Without further delay, let's take a look at some of these problems and think about how we can improve them from an engine development standpoint, so that I can sleep tonight without another quaternion nightmare. First of all, we need to understand what scenes are in Godot. If you're familiar with Unity, a scene in Godot most closely resembles a prefab. It's a collection of objects that can be instantiated many times and even nested within each other to create complex game systems, level props, and entities. Wait, a collection of smaller objects that are grouped together? That also kind of sounds like a level, right? So yeah, Godot scenes are also Unity scenes. This makes sense coming from other engines, and there's even familiar features that let you work with scenes the same way you would a prefab in many cases. You can inspect the children of a scene when it's instantiated through the editable children option. You can create variants by creating an inherited scene, and there's even a pull request in progress that would allow you to push back instance changes to the base scene, sort of like the Apply Changes button in Unity. Side note, please go give this pull request some support. I would love to see it merge for 4.5. So that's all pretty neat, but some parts of how scenes work are built on shaky assumptions. Let's talk about these now, but just to preface this discussion with reassurance, I'm doing my best to address these flaws in good faith, and it's not meant as an attack on the engine as a whole or on the people who work on these systems. I'm sure there were plenty of good reasons to implement scenes in a specific way while they were being developed, and oftentimes it comes down to creating smaller PRs for review and taking the simplest, most direct option to accomplish certain goals, and that's not necessarily a bad thing. But here I want to challenge some of the core ways in which Godot works and hopefully offer some ideas to improve the situation that don't mess with the intent to create a flexible, easy-to-use game engine. With all that out of the way, let's crack open the problem of scenes. When you create a scene, all of the values of each property that exists within it are stored and become default values whenever that scene is instantiated. So for example, if I bring in this beautiful little drone model, her name is Yui, and create a new scene with this blue circle's visibility set to disabled, then every time I bring in the Yui scene, that circle will stay disabled. Okay, cool. So let's bring in a few more of these and test what happens when I turn on the circle in the base scene. Perfect. As expected, every instance of Yui was updated so that the circle became visible. Let's say I have different use cases for each instance of Yui. On this special perfect version of Yui, I want the circle off. So let's make the children editable and just turn it off. You can see that we have a little revert button appearing, which shows us that the value is different from the default which comes from our scene. Alright, so that worked. Now let's say I decide I actually want every Yui to have the circle off, so the most straightforward option, especially if I had hundreds of these things, is to go into the base scene and change the default setting. Let's see what that did. Okay, so all instances were updated, and that again makes sense. Now 3 months have passed, we're entering crunch time on the development of my Drone Paradise game, and actually I've changed my mind about the circle. I now want default Yui scenes to have the circle enabled, so that's exactly what I do. Let's go back to the instances and... oh, wait a minute. Didn't I have a special Yui that was always supposed to have the circle off? But now she's become normal and lame and has followed the rest of them by enabling the circle. What happened here? The answer is that Godot determines if an instance scene property is overridden by comparing its value against the base scene. That's the only check it does. So if at any point the value matches the default set in the base scene, it becomes synced and permanently follows it. Okay, so what, I hear you ask. Well, imagine if I had 100 drones in my amazing MMO, or 200 units in an RTS game, or 500 procedurally placed tree assets in an open-world adventure. Now the problem has become pretty tough to deal with. If I wanted one or more of those scene instances to have unique properties, I'd have to keep a mental note of any differences and make sure not to accidentally sync them to the base scene. Or if I do, I have to remember to change them back if the base scene is updated again. So is there any way to solve this with the tools that Godot provides? Actually yes. If you right-click a property and hit the pin button, it will lock the value of this instance property, no matter what the base scene says. You'd think that would allow us to bypass the issue, but as you probably guessed by the existence of this video, there's a few problems with the pin feature. For one, we're now dealing with another system built on top of the override behavior, and it can be easy to confuse the two, especially for a new developer. If you're trying to create overrides quickly, you might forget to activate the pin and end up with unintended behavior. Another problem is that it takes additional time to right-click and select the pin button, when I can't ever imagine a scenario in which you'd want to leave the pin off. Perhaps this will be more convenient if and when we have the ability to manage individual property overrides by right-clicking them, but if you want something to be distinct from the base scene, just changing the value should be enough to trigger that. Finally, the pin feature just straight up doesn't work on transform changes. That means there's no way to enforce that scale or rotation overrides will remain. And speaking of transform changes, I've now decided that all UEs in my scene should be scaled up further to make them even more magnificent while in-game. Well, now that we know about overrides, this should be easy to accomplish. Let's just double check here, so none of the scale properties are pinned, this pinning doesn't work on scale anyways, and they're all at the default value of 1, which means they should be synced whenever the base scene changes. So let's go into the base scene, scale this drone up to 2, and nothing happened. Clicking on one of these instances, it seems Godot did recognize that the default scale changed because there's a little revert button here, but it didn't actually update the instances to follow the defaults. And if I click the revert button, it works fine. What gives? It turns out this is intentional, I think. This is just how scene root transforms are handled, and I believe it was done to prevent mistakes, which are kind of tied to the whole problem of overrides I showed you in the last section. Let's say, for example, I wanted this UE to be at the coordinate 0, 0, 0. Now I go into the scene root and accidentally change the default position to something else. Well, now my UE is able to stay at the 0, 0, 0 position because the scene root transformations are not accounted for. Kind of useful in this circumstance, but the unfortunate side effect is that now entire workflows are cut off from being viable. What if I wanted this instanced UE to be moved to the new default position? Or, as a more common example, let's go back to the scale changes. If I want all UEs to be scaled, it's not a mistake to change it in the base scene, but now I can't update the scale properly without going through all of my instances and clicking the revert button. I'm not sure exactly what the thought process behind this was, but I believe this was done specifically because pins don't work on transform changes. Because if scene root transforms did cascade, and without pins available, it's now impossible for me to say that I want this specific UE to stay at scale 1, without affecting it when I change the defaults. But this wouldn't be a problem if the override stayed, because then a developer has the chance to enforce the instance change. And if the scene root changes did cascade, and you made a mistake, you could easily just change the defaults back and they would follow correctly. Okay, so that sounds a lot better, but that's not how Godot works right now. What exactly is the solution for this problem if we're working with the current tools? During my discussions about this topic on GitHub, one suggestion I heard was to create a child node that handles the default scale, which can be any value, while leaving all the scene roots at scale 1. This can work to at least propagate scale changes correctly, but there are a few issues. Let's use rocks as an example here because they're more commonly understood to have varying scales. For one, it would be nice to actually see the asset scale immediately when you click on it. In Unity, I'm able to just click on a rock and see that it has been scaled to a certain value. But with a child node, I have to go into each instance and change that scale, which means I need editable children always on. This is pretty annoying and can slow down things quite a lot. To mitigate this, it was recommended that we work off of the default scale and just multiply it using the scene root transform. That sentence was hard to follow properly, so let me demonstrate the problem with this approach using an example. All rocks have a child node that is set to scale 1.5 to enforce their default. So I start placing rock instances around my level, but on this instance, since I want the rock to match some sort of look, I scale up the root to make it look nice. Okay, great, but then I decide that I want the default scale to be a little bigger. So I go back into the base scene and increase the scale of that child node to 2. Going back to the level, my unique rock has now lost the scale that I wanted it to be, and now I'm forced to go back to it and scale it down to match the new default. This happened because I wasn't trying to scale it relative to the default. I was trying to scale it to match some specific absolute size that worked for my level. In other words, it is simply impossible to work this way without a lot of manual fixes each time the scale changes. Yui is not happy about this, but at least she can speak her mind. What was that, Yui? Did you say subscribe if you liked the video? To top it all off, this solution introduces another node to worry about, which complicates the hierarchy and can exaggerate performance issues if used too much. This is because it's been documented that the performance of a Godot project is directly impacted by the number of nodes. And although one extra node doesn't sound like a lot, needing an additional one node to create a cleaner workflow on every single level prop can add up to thousands of extra nodes, depending on how many props you have. Overall, I imagine it's not too terrible to deal with this aspect of the workflow, but it's definitely still concerning as an extra problem on top of everything else. How exactly can we improve the Godot engine to mitigate these issues? I've got a few ideas, and would even be happy to look into implementing some of them as PRs when I have time. So let's discuss those for now. For the overrides issue, this proposal is a good start, and I think the best way to implement it is either to extend the pin system to work in more cases, alongside an automatic pin feature that activates anytime you change value, or even better, remove the pin system and port its logic over to all property overrides. For that approach, which I definitely prefer, anytime an override is present on a scene instance, it should be treated as if it was pinned. The revert button doesn't change the value but removes the intent to override completely. With this system, there would be no more accidental property sinks, and users don't have to worry about an additional layer of complexity to manage overrides. As for the scene root transformations issue, this GitHub user has discovered that scene instances that have 0 transformations across position, rotation, and scale do actually reflect their base scene defaults. I'm not completely knowledgeable about this subject yet, so I apologize for any inaccuracies, but it could be that all transformations are considered together, which might have something to do with the node's basis values, basically a matrix that stores transformation information. However, it's clear that at some stage Godot does understand that the position, rotation, and scale are individually different from the default because of the revert button in the inspector. So I'm not sure if the scene root transformations issue is really intentional or just a result of this bundling of all of the properties together. So I believe one way of fixing this could be performing that check ahead of time when the base scene changes to see what is different, and then adjusting whatever internal values are needed to make the transform appear as though it has reflected properly. Combined with the override changes, this would allow scenes to nearly reach parity with Unity's prefabs, which from my perspective would be a huge win. Whatever the solution ends up being, there must be some way to propagate the scene root changes to each instance. In my opinion, this is an extremely important change that restores user trust in the consistency of Godot's scenes. It's hard to picture designing levels the way I used to with these current tools, because I tend to rely on scale defaults for a lot of duplicated assets in my games, as well as rotation defaults for UI elements. I'm also planning on creating procedural landscapes and forests in Godot, which would involve placing a ton of assets like trees, and I believe a lot of frustration and accidents could be reduced during this process if scenes worked more reliably. Thank you for going on a journey with me through this conundrum. One thing I want to stress is that despite this proposal impacting some of the base functionality of the engine, I don't want to uproot the existing ways that people work with Godot. But if you have gotten into the habit of creating scenes with a scale of 1 and scaling relative to the default created by a child node, that workflow is still possible if both of these problems I discussed were fixed. And the same goes for the other ways that people commonly use scenes. Nothing I've suggested here should affect your ability to work the way you're used to. But with these problems addressed, it would open up the path for other workflows that are more familiar to the way that other game engines work. At the end of the day, opening up Godot to more people should be a worthy goal, and I believe these issues completely break someone's experience with the software if they're used to other development tools. But that's just what I've been dealing with. I'd love to hear what you think in the comments below, and I'm always happy to bounce around more ideas that can improve Godot, as well as learn more tricks that might have flown under my radar while researching. If you liked this video, subscribing to the channel would help a lot, and show me that you guys are interested in these sorts of topics. I've got more videos on the way as well, with the next one focusing on my level design process. So if you'd like to keep up with my latest announcements, feel free to follow me on my socials, and as always, thanks for playing.